Cool. Hello, everyone. Thank you all for joining today. My name is Ananya Roy. I am a specialist solution architect here at Databricks. And what I'm going to talk about is a pretty important and relevant topic when we are working with agents, and that is becoming more and more predominant nowadays. So it's about how we build these type of systems responsibly. So a couple of key takeaways I want you to get out from this session. Number one is there is a fundamental shift in our thinking about how we have been utilizing or implementing responsible AI practice and how it changed when we are talking about agents. So that's something which we are going to talk about today. I'm also going to talk about why the way we have been creating different matrices, those are not sufficient when we are specifically talking about agentic systems, and what is the need for custom matrix. I'm going to show some of those capabilities through Mosaic AI Evaluation Suite. If you have been in this session today or yesterday, you might have seen there are a lot of announcements on this product. There are a couple of product sessions as well. Just a disclaimer that this is not a product deep dive. There has been other sessions by the product team. So if you are interested on understanding more about it, highly encourage to watch those sessions. And lastly, I will basically conclude my talk with some of the best practice which I have been seeing across different customers and what we should be thinking about when we are thinking about an automated evaluation suite for your agentic application that is trustworthy. Now, just to understand about what is responsible AI, right? So from the lens of agents, there are a couple of different pillars. And I'm not going to cover all of them, but the major ones I'll cover today. So number one, it's a given, accuracy and evaluation. So it is important when you are building this type of production application to assess how accurate they are performing. And there are different measures in which we are going to cover today. Observability and transparency. So that's one of the pillar which goes kind of hand in hand, which basically says that I'm not only going to look at the output quality of my agent, I'm also going to understand what is happening at the internal level of this agent. So that is actually giving me quite a good understanding of how my agent is working. And I foresee a future where we are not only talking about agent in itself, we are more talking about a software application where agent, GenAI, LLM is basically one part of the equation. So that becomes important. Second is safety and guardrail. So if you are building a state-of-the-art application and you do not have any safety and guardrail measure, you might as well not go into production. So that is really important when we are talking about implementing a responsible AI for an agentic application. Human-centric, I think we have been talking a lot that no matter whatever state-of-the-art application you are building, you need to have human in loop. You need to have that final control of your SME or your human or whoever you want to have that final say whether this application is trustworthy to go into production, or if things go wrong, what should I do and how should I do? Number 4 and 5, basically, yes, 4 and 5 are basically about production. When we talk about productionizing these applications, application monitoring and security, these two matrices are also pretty crucial. That's basically saying, say you have evaluated your application, it's working as you expect, but there is no monitoring system in production. Then how would you ensure that these applications are performing as you expected? So monitoring and security goes hand in hand. And last but not the least, governance. That actually goes basically for all of them. Whether you are building, whether you are implementing, whether you are monitoring, governance should be the basic principle which should be present in all and every aspect of your agent system. For the purpose, because this is a very huge topic, I'm not going to cover all of them today. what we are going to cover today is these three. And I'm going to go a little bit more detail on these ones in the subsequent sessions. So why evaluation is important? It's kind of like self-given of I am building some application, be it a data application, AI application, I need to ensure that that is working as my expectation. But I just want to put some real world examples in this case to make things more relatable. Chevrolet was one company who has built one conversational agent for their user, and one of the user, they later bragged about it, is they were able to manipulate the prompt and got a $76,000 car in $1. And because it was done through the official channel, there has been legal proceedings which has happened afterwards. So it's a pretty big risk factor. Similarly, for Air Canada, very similar situation happened where their conversational agent was interacting with a customer and provided, due to some misleading behavior, provided a refund more than the said amount, and that went on to subsequent court cases, whatnot. So the idea what I'm saying is that you will get more and more applications like this, but if you do not have the right evaluation practice or a trustworthy application in place, these situations are bound to happen. Before going into the detail of how would we do it, what are the different ways we can do it, there is some fundamental things which I want to clear. Number one is evaluating a language model is not equal to evaluating your AI agent. And let me unpack that a little bit more. So when we are talking about LLM evaluation, we are basically talking about the capability of a language model to produce an output. What does it mean by that? I have an input, and then I am evaluating how good the language model is producing the output, be it a summarization, sentiment analysis, categorization, so on and so forth. So your environment is quite constrained, and you already know what is expected, at least in some sort of form. But whereas agent is different. Agent is not only generating answer, it is giving you an output, basically doing some action. So things becomes completely different when you are expecting to do certain things for an application. Similarly, for language model, as I mentioned, your environment is static. You are using different types of user parameters or user question. But for example, in a summarization use case, no matter what type of user input you are giving, you expect a certain summary. So that's the end of it. But for agent, it's very different, because what you are doing is output are changing based on your information or based on the user input. So if one user is asking a question which is taking 20 different tool executions for the model, then it's a complete different ballgame altogether. And similarly, when we are thinking about agent, majority of the time, if you have already built it in your organization, they are purpose-built. So you should not be validating a code-generated agent with a conversational agent. The metrics will be completely different. So, and last but not the least, cost. And I think that is something which is not spoken quite widely, but I think that is really relevant. The reason because for language model, at least if you know the input and the output token length, you can estimate the cost. Maybe not 100%, but you can estimate. But cost is unbounded when we are talking about agent. And the reason because, as I mentioned, you can get for one individual user question, you can get one tool execution, and then you get the answer. But for a separate user question, you might think of there are multiple sub-agents which are calling each other. They are going in loop. They are getting information from n number of tools. So you cannot predict that beforehand. So cost can quite easily go off the ceiling if you are not kind of like considerate about cost when you are evaluating these type of applications. So let's understand evaluation a little bit more of what we are doing today and why I am saying that that might not be sufficient. So let's imagine you are creating one AI application And then one of the most common use cases which we are seeing across customers are maybe some sort of a batch use case, summarization use case, classical sentiment analysis, whatnot. You have certain guardrails and certain type of evaluation practice in place. Example, statistical matrix, human in loop, LLM judges, all those things are fine. Again, sometimes you're using RAG type of agent. Then you're using the different matrix like context relevance, groundedness, so on and so forth. But if you just take one step back and think that all of these are on a high level looking at the output quality, you're still thinking of your application as a black box. Maybe not so much for RAG, but overall. So it is looking at how your output quality is, but it's not going inside your application or inside your agent to understand how it has derived to this situation. And that becomes really important when we are talking agent, because there are multiple tools, multiple things are coming together to give what the user want or what you want. So it's kind of quite analogous to say that you are not judging a chef by the dish he produces. You're basically looking at what ingredients was used, how he has come into this conclusion, or how he has created the dish, not basically burning down the entire kitchen to give you the dish. Right? So that's the idea of we should have an understanding of each and every step of your agentic workflow. Now, custom matrix. What is the reason these standard matrix are not enough? I'm going to give 3 different examples just to put things into perspective. So we start with a simple summarization, then one of the most common one, which is RAG, and then we are talking about agentic apps. So for example, summarization, majority of the statistical matrix would be sufficient today if you are working with a summarization problem. They can say very well how it has summarized, so on and so forth, if it's coherent, whatnot. What if I want to understand more? I want to understand if this summary has captured my company's risk policy or not. Has it captured the relevant information I need which is relevant for my company? Has it done that? No. Can I assess this? If I go with the normal standard metrics? No. For RAG, if I want to ensure that all of the retrieval contexts are coming that are always the latest and there are no duplicate context which is returned, can I do that with current standard metrics? No, we can't. And things becomes wild when we are talking about agent, because for agent, some of the basic question we should be asking is whether the right tool was called or not, whether the routing was correct or not, whether the tool's trajectory was right or not. We won't be able to answer these if we go with the standard matrix or standard way of evaluating. We need more. And that's where custom matrix comes in, which is basically saying create your matrix so that it is aligning with your business goal and that matters to you, and just not some random generic metric. I'm going to explain that a little bit with a hypothetical scenario of a financial portfolio analyst, and that is something which I'm going to demo as well. So let's imagine I have built one agent, which is a portfolio analyst, and there are multiple tools involved, and this is giving suggestions to customer on their portfolio, what they need to do, understanding fraud, so on and so forth. So with that, say for this agent, user comes in and they ask a question about, I want to rebalance my portfolio from stock X to stock Y by 10%. Can you tell me what would be my future situation looks like, whether I would be in profit or loss? Explain it to me and give me a suggestion. That's a loaded question, because the agent need to n number of things to give you a correct answer. So there is a bit of planning involved. The model will understand this, so the brain or the model, which is kind of like the center part of an agent, if we are talking about single agent, they'll understand what are the tools I have, what are the tools I need to execute. So for example, first, it needs to understand what is the current portfolio status for this customer. Then it might need to go and find out the relevant stocks this customer has, perform certain sort of simulation, and then give user the result. Fraud selection, detection, this is one of the tools present. Would this be important for this question? No, might not be. So the agent need to assess what are the tools it needs to execute and then execute it and give the result back to the user. So what you're seeing here is that it's not only one single component which is making the decision. It's a combination of all of these. Now, how do I ensure of such complicated system? And this is not complicated. I'm sure that for your organization, your things must be much more complicated when we are talking about real use case. So how do I ensure that this is actually, I build some sort of a responsible system which is trustworthy, I can trust so that my customer also can trust. Number one, we need to assess the overall quality. That's a given. That's non-negotiable. You need to kind of like assess how it is performing. That's what we are doing today. No problem in that. We also kind of like crack open this agent and understand the inner workings so that I know that based on certain user question, the routing has been correct. It has gone to the right tool. It has gone to the right sub-agent if need be. The trajectory, that's quite interesting. And I'm going to show you in a moment. Once you have understood that, okay, maybe 5 different tools need to be executed in order to answer a particular query, sometimes the execution order is also important. So for example, in this case, if the stock analysis tool has been executed first before the portfolio analysis, basically it is null and void because what we are extracting, what we are looking for, if we don't even know what is the status of the customer. So sometimes this trajectory is also important, not all the time. Chain of thought reasoning, if we are using some state-of-the-art models, majority of the time that is the case, we need to understand if this decisioning is logically consistent or not. And it's very similar to planning. So the planning has been correct, whether the execution has been correct or not. And I can go on and on, but these are some of the things which comes top in my mind in terms of evaluating an agent. So what I have done is I have talked a lot about different ways of evaluating, whatnot. So what I've done is I've created 3 different categories. That is something kind of like a ballpark figure you can think of when you are building this type of application. Number 1, I'm calling it as a macro matrix, which we are already doing today, which is basically the standard matrix like statistical matrix, relevance, correctness, then safe, toxicity, bias. These matrices we should be doing regardless. We should be validating these matrices regardless and see how it is performing. So that's that. And then I'm going to also validate something called micro matrix, which is basically the inner workings of your agent, the entire execution flow of your agent, and understand how the agent has come to a conclusion and what are the reasons. So it's giving you that why and how answer. Some of the matrix would be, as I mentioned, routing and tool calling, tool path, trajectory, individual tool output. So a same tool with different parameters would be giving you completely different result. So whether the input and output was also relevant or not, that's something you can also check. Basically, you can go as deep as you want if you have the right information. Chunk relevance, so on and so forth. And I can go on and on, as I mentioned. And then, so these are all micro. And then we cannot forget about the performance matrix. Because as I mentioned, cost can really go up to the ceiling if we are not considerate about it. And think about the situation that you have 2 agents, both of them been asked the same question, both of them has given you the correct result. One has executed 2 tools, another one has 20 tools. Which one should you choose? Because every tool execution is associated with a cost. So cost becomes important when we are thinking about production scale applications, we are scaling with multiple customers, so on and so forth. So how can you make kind of like a generalized architecture of a robust evaluation framework? You have your AI application, you have the macro matrix, you have the micro, and then you have your performance. All these three things together can go into your business decisioning process. And with all of these metrics together, you can make an informed decision of what should we do. Should we ship it into production? Should we do some sort of tweaking? So on and so forth. Now, I have talked enough about matrix, evaluation. Let's talk a little bit about observability. Everything I have talked about in terms of tool, trajectory, so on and so forth, how can I achieve that if I don't have the right information? And that's where observability comes in. That is basically saying I have all the information I need to create those metrics that is relevant to my business need. So I am not considering my application as a black box. I am fully aware of how any conclusion was made. I know the why. And then the way I can do that is if there is any mechanism through which I can log every execution of my workflow. And that inevitably will be increasing trust and reliability on my application. If you ask on Databricks how we can do that, I'm sure you have heard about MLflow trace. So MLflow trace is our capability when you are building agent inside the platform. It has the capability of kind of like take a snapshot of every execution and then hold all the information about that trace in a format that is kind of like widely accepted, which is open telemetry format. So in this picture, what you are seeing is one single execution. You have your agent, you got the final answer. You can see at every span what has happened, and then what was the tool that was executed, and it can grow more. Trust me, trace can go more because your execution can be complex. So that's observability. Safety and guardrail. I think I have talked a lot about this, but this is just kind of like a guiding architecture. I know for real use cases, it can be quite fluid, but the idea here, what I'm trying to say is, if you are building your agentic application, if you have evaluated, you need to have some sort of guardrail. So whether those are dev guardrails like safety, toxicity, bias, PII detection, whatnot, or whether these are production guardrail, where it is saying, I have the correct rate limit, I have the usage tracking, so that I know if something go wrong, I have all the mechanisms to prevent it, or if it happens, I know how to backtrack it. And it's completely up to you whether you kind of like combine all of these guardrails into one or split it out. But the idea is there has to be some sort of guardrail mechanism which should be present when you are building and planning this type of application. Now, let's understand a little bit about how we can do this in Databricks. Now, I will show some of the capabilities of Mosaic AI Evaluation Suite, and then from the lens of a financial portfolio advisor agent, which I have already mentioned. So, okay, this is what I have built. So this agent, what it is doing is, it is, as I mentioned, a financial portfolio analyzer agent. I have created a bunch of different tools here. Some of them are extracting and authenticating customer. Some of them are extracting portfolio details. Some of them are looking at the internal knowledge base, portfolio rebalancing, so on and so forth. I have stored all of them into Unity Catalog. And then I have created an agent and served it via model serving endpoint. That is my agent, which I am kind of currently using everywhere. Now let's understand how I can evaluate the performance. So that's my goal. I need to understand how my application is performing. So I go here. What I have done and what I'm showing you here today is I have run my application across different type of questions. And those questions I have kind of like deliberately created some edge cases question because I want to ensure that my application is performing well. Because to be honest, let's be honest, we can't trust humans. They can ask any questions in any format because we are intelligent species. And that's why, to best of our capability, we can create as much as possible test cases to assess how my application is performing. So these are this is the UI, how it is looking like. Now let me go through with some of these metrics. What you are seeing at the right-hand side, they are all custom metrics, which is I have created this. Some of them are called as, for example, it's saying conflict of interest scorer, which is basically saying the output which I am producing, is there any conflicting information that can kind of like have a negative impact on my reputation. Correct routing, which I mentioned earlier, whether the routing is correct based on the user question. How can I do that? And remember, all of these I have created with the help of MLflow trace, the inputs and the outputs. That's it. That's only the information which you need. Safety, tool trajectory, total number of tool count. And that becomes quite relevant. For example, if I am trying to assess multiple different agents or multiple different versions. If the same questions is answered with a smaller number of tool call, then obviously I will be choosing that agent. That becomes kind of like higher in my performance bar. Now let's unpack some of these custom matrix a little bit more. Let's see some of the faults. What I can see is that routing is 83% correct, 17% incorrect, which is not what I want. Maybe let's double down on this question a little bit more. So the question which was asked is, my name is Daniel Johnson with postcode blah. I want to rebalance my portfolio from Netflix to Amazon by 10%. I want to understand what would be my future portfolio looks like, provide me some suggestions, blah, blah, blah. Now this is our latest kind of like UI, and I'm going to show you the code also how you can achieve this. So what you are seeing here is a summary version of your agentic execution. So you have got your chat, then it is executing multiple different tools one after the other. First, it has extracted customer details, then portfolio details, simulation, stock inquiry. Now, I'm not sure about stock inquiry because I don't think I need to get a real-time stock inquiry. That is quite suspicious. I need to look onto this one a little bit more. Then internal knowledge search, but yeah, I don't need this, but why it has come up? So this is my debugging process. If I want to understand a little bit more, I can go into the detail, and you can see the detailed execution flow, the inputs and outputs of every execution, how MLflow traces, and what were the input, what were the outputs, so on and so forth. So this gives you a detailed idea. Now let's look at the scorers. Scorers are the matrix which I have been talking about. Let's look at the one which has been showing as false. So false, it's saying, so false is based on my ground truth. I already have created my ground truth data saying that if the question is on this route, you should be. Now there are a number of ways which you can create your ground truth. You can take help of LLM Judge, or you can create your own bespoke ground truth data as well. So there is no problem in that. For this use case, I have said that if the question is about portfolio rebalancing, then the expected one is about you would authenticate your customer, then subsequently extract your portfolio details, then you would be performing a simulation of rebalancing and whatnot. But ideally, the model has actually gone too far, and it is actually more intelligent than I believe. So it has gone and then done all those three things and also extracted those real-time stock of Amazon and Netflix currently as of today, then went into my internal knowledge search, find out relevant information, and then provided a suggestion. And that might be correct in some situations. But if I'm in a highly regulated industry and I have strict guidelines of what to follow and what not to, and maybe maybe my company does not want real-time stock information, but it has gone regardless. So then it can create a problem. So that's how tool trajectory is one of the metrics that is giving me a little bit open idea about what's happening under the hood. Similarly, if I look at the other matrix, so total tool count, number 6, which is quite big in answering this question. But it can be expected if the question is complicated in itself. So if you have right ground truth data, you can evaluate your model's execution based on your ground truth. And if you don't have ground truth, then also there are ways you can generate ground truth through your SME evaluations and whatnot, or you can actually use other matrices which are not reliant on ground truth. But if we are talking about understanding the tool calling and flow, then ground truth is important. These are not related. The reason because this correctness and relevance to query are specific because if we are using internal search and whatnot. Safety is fine, correct routing. So for example, I always want to ensure that user is authenticated before answering any questions. So that's why extracting customer details are important. So that has been done here, so that's why it's a pass. Now, it is not bounded by this Boolean true or false value. You can also create this number. So Boolean, numbers, decimals, whatnot. You can create this kind of like a quantitative matrix that you can use in your automated evaluation workflow. So no one is stopping there. So that's a pretty powerful UI, as well as you can get data frame to make a robust evaluation pipeline. So that's that. Now, if I come back on how have I achieved this. So I'm not going to go through all the bits of the code, but what I want to say here is that it's pretty easy to build these applications in itself and custom matrix. So for example, I have provided this prompt saying that, okay, for conflict of interest, this is my prompt. I have mentioned this decorator. This is how MLflow understands of how it is a metric. So with the scorer function in MLflow 3. And the only thing which I need to be worrying about, MLflow GenAI evaluate. That's the part which is doing all the magic which I have been talking about. And then you pass your data and the metric, and rest of it is self-explanatory. So with that said, what you have seen here is that it is pretty easy to build custom matrix, and basically the world is your oyster here. As long as you have the right logs and the traces, you can build custom matrix that matters to you and build a trustworthy application. Now, with that said, I want to show you what are some of the best practices you can take when you are building a robust evaluation pipeline. So, when you evaluate, what are kind of like some of the best practice you can take? Number one, say you have, obviously the first part is building that. Once you have built it, you create a good test case planning, which would be, ideally it should have some sort of simulation of good test cases, bad test cases, adversarial scenario, whatnot. Then you generate ground truth data if you don't have. If you have, then well and good, you don't need to worry about it. But if you don't have ground truth data, then generate it. We have our evaluation generate eval data frame API. That's pretty easy to generate these synthetic data. And then you perform the evaluation, and then you iterate upon it. So there is a way in MLflow Trace, and I'm more than happy to show you afterwards if you are interested, to basically compare different runs. Say for example, you have changed your prompt, you again run it, your application performance has gone up by 5%, and you want to see the difference. So iteration is important. There is no single answer when we are talking about GenAI or ML in general. So you iterate upon it. Once you're happy with the application or the output, then you go into production. And production monitoring should go hand in hand. Do not kind of like think about I can do it later, because this becomes more and more important, even more than evaluation when things are in production. And that loop which I mentioned earlier should be going, there should be some sort of feedback loop which is going back to your agent development lifecycle, and whether you are validating through humans or through any alert mechanisms, through machines, that's up to you. But that's the overall flow, I would say. Now, how we can help? I have shown a part of that application. How we can help is, in this application, we have everything which is needed for you to enable yourself to build this application. We have Mosaic AI Development Suite, which is helping you to build that agent. Then we have got our evaluation framework, which is having everything, as I mentioned, in terms of building a robust pipeline. And then tracing it's kind of like closely integrated with all the services which I mentioned, and lakehouse monitoring. There were some talks about lakehouse monitoring, I think in the keynote and also in the session, that is actually talking about how we can create even more robust production monitoring system when we are talking about GenAI. So all of them together are helping you to build a trustworthy application. Now, I want to conclude my talk by saying that we have understood a lot of different things. The first thing is we have gone through the different pillars of responsible AI. We understood what is important and how we need to think a little bit differently when we are building and evaluating agentic applications. Why custom metrics are important and how we can build it. Visibility, observability, and trace, that's prime if we want to implement this in a proper manner. And then guardrail implementation is also kind of like goes quite hand in hand. I would conclude my talk in a sense that this place is moving at lightning fast speed. The thing which I'm talking today might not be relevant 6 months or 1 year down the track. So we need to think about when we are building this system a little bit future proof. So that's why we need to build a system in such a way that these can adapt to the newer changes and make it modular as much as possible. So with that said, thank you everyone for your time and have a good rest of your day. Thank you.